So we want to be able to look and see what is a redox reaction, be able to say yes, it's a redox reaction or no. And then once you figure out if it is a redox reaction, then start giving oxidation numbers and figure out which was reduced and which was oxidized. Tomorrow's quiz will not have redox on it, and it will not have what I talk about today on it.
So it'll be like I don't understand redox. What's a redox?
That learned it yesterday. You'll have to go watch the video.
Our test is on Tuesday, right?
Our test is on Tuesday, yes. Okay, so any free element, if you look at these reactions and you see reactions that have free elements, which means they are not hooked up with anything, anytime you see those, you know those are redox reactions. There's going to be a transfer of those electrons. This one, there's not going to be any transfer of electrons because nobody's going to change its number. So I know the last one is not a redox, but everything else is because there's free elements. Every free element has an oxidation number of what? 0. These are ionic compounds, which means their oxidation number is what? In an ionic compound, they become ions, which means they have a charge, which means their oxidation number is what? Their charge. So the oxidation number of chlorine here is -1. The oxidation number of iron is +2. Sodium is +1. Now I look at that and I see who changed their charge, who gained or lost electrons. Everybody but Cl. Cl is a -1 and it stays a -1. So my next thing is we have Na and we have Fe. What we want to do is we want to look and see how did their charges change. So Na went from a 0 to a +1. Fe went from a +2 to a 0. So whose charge went down? Fe. So that means it is reduced. And that means sodium has to be oxidized. Okay, so let's do number 5. Copper reacts with nitric acid to produce copper 1 nitrate and hydrogen gas. So any free element has an oxidation number of 0. And these are ionic compounds. So their oxidation numbers are equal to the charge. So the charge of nitrate is -1. Hydrogen is +1. And copper is +1. So whose oxidation number did not change? And that would be nitrate. So nitrate's out of the picture. And we are left with copper and hydrogen. Copper goes from a 0 to a +1, and hydrogen goes from a +1 to a 0. So whose number went down? Hydrogen's number went down, therefore hydrogen is reduced, and copper is oxidized. Okay? Do we need to do one more? No? Yes? No? Let's do one more. Let's do number 2. Any free element has a 0. I've already said it says 0 there. We know that hydrogen is always a +1. There are 2 hydrogens for a total of +2. So in this case, it has to equal 0 when I add them together. So what does carbon have to be if I have 2 of them? -1 for a total of -2. Oxygen is always what?
2.
A -2. -2, and I have two of them for a total of -4. So copper here has to be a +4.
How do you do it?
Oxygen's a -2, and hydrogen's a +1.
Wait, so hydrogen's always a +1?
So whose charge did not change? Hydrogen. Okay, so then we say copper goes from being a -1 to a +4. And oxygen goes from being a 0 to a hero, -2. Whose number went down? So therefore, oxygen is reduced. And that means carbon is oxidized. Okay? Am I not cold? I go, It does say. We're state champs.
Wait, what?
Remember that day we were out of school? That snow day? We went snowboarding. We had a competition.
No, aren't they like NHS shirts? They're like jokes. Teams that would never be. There is speed walking.
Speed walking.
There's like lacrosse.
And lacrosse. Okay.
I wish we had a
All right, guys, let's refocus. So what we're going to talk about today is the activity series of elements. So what you need in front of you is this yellow chart, or you might have one that's white, but the blue ones will not work. Flip over to the part where it says solubility rules, and then you see a little, over here to the right, or to your left, it says activity series. And then there's a bunch of metals listed there. And you see that the arrow is pointing up, saying increasing activity. So this is a resource that you use, or we can even use it in the lab to decide if a chemical reaction is going to take place. This tells me the ease at which something can replace something. So if I'm talking about something replacing something, I'm talking about a single replacement reaction. So if I had, say, sodium chloride, and it reacts with lithium chloride. But I can look at a chart, this one right here that you have in front of you, and see if that reaction is going to happen or not. So what I do is I like to think of this as team rankings, or whatever you want to think about. Basketball, football, whatever. So you think of if you're looking at your solubility rules chart, you have your top team. And then you have your bottom team down here, which on here should be gold. It's fallen off. But it's how easy is it for this top team or this bottom team to be able to replace something else. So if you're the top team, how easy is it for you to beat this one or this one or this one or this? It's pretty easy. But if you're here at the bottom and you have a losing season, then who is going to be, easy is it going to be for you to beat these teams up above you? It's going to be pretty hard. Okay? So that's the way I like to think of that. So now I look and I have this reaction, and I look and I see it's single replacement. Who is lithium going to want to replace in this reaction? Lithium wants to replace sodium. We have a metal and we have a metal. So the metal wants to replace the metal. So can lithium, looking at your chart, can lithium kick sodium out of this reaction? Yes. Yes. When lithium kicks sodium out of this reaction, sodium is now by itself, and we get lithium chloride. That's it. Yes, you do. So what about this? What if we had sodium reacting with lithium chloride? Can sodium kick lithium out? No, sodium can't kick lithium out, so we're not going to see a reaction. We have an R, no reaction. Okay? So that is how you look at it. So look at this. Tell me, what are your metal? What's your jewelry made out of? Gold, silver. What else? What type of metal? Titanium, platinum. What about our change? Our money? Copper, nickel, zinc. Where are they at on this chart? They're way at the bottom. Okay? Because you don't want to have something that's really reactive around your neck or something really reactive in your pocket. If you have money made out of lithium in your pocket and you put something else in there, then you're going to start feeling really hot in your pants, and it's going to be probably a fire or something, a reaction, chemical reaction. Huh?
Oh yeah, you did that with like a
Okay, so that is what the activity series is. Now, the thing I need you to know is these are all metals, but you will see them for nonmetals. And the nonmetals that you will see are I bring clay 4. So those 4 are ones you will see in a reaction. And they are just like that on the periodic table. And when you go up the periodic table, we have increasing activity. So if I had an AI and I react it with fluorine, will that reaction occur? Who does fluorine want to replace? It's a nonmetal, so it wants to replace I. Will that reaction happen? Yes, fluorine can kick out I. So when fluorine kicks out I, we get NaF and I2.
Is that like its own gene?
Oh, okay.
I didn't think so.
Okay, what about here? Sodium bromide and iodine. Can iodine kick bromine out? No, so we would have no reaction.
Oh, I got you. Wait, so only non-metals can kick out non-metals?
You can only kick out the one, well, yes. The only exception is that hydrogen.
How do you kick out everything?
No, hydrogen's right down here. Okay, so let's do some practice. Yes. Your homework tonight is going to be on 1 through 15. You're going to classify those, further classify them as redox or not. Look at them, see if they're redox or not, and try to classify them. And then your other part of your homework, the other part of your homework is 1 through 7, where you have to do just like we're doing here, and then balancing it. So, A, who wants to replace whom?
Let's see. CL's no. Yeah.
Lithium wants to replace sodium. Can lithium replace sodium?
Yes, they can.
So when it does, we get LiCl and
How do we know that it wants to replace them though?
because it's a single replacement. These are all single replacements.
I don't think he gets why it's lithium.
Why wouldn't sodium just try to kick out lithium? And like
Why? Where's sodium kicking lithium out to?
I don't know.
It's the one that's by itself wants to get into the grouped one.
Oh, okay, that actually helps. The one that's by itself wants to get in the
So it's wanting to cut into the dance. So,
I got it.
okay.
No, I got it.
I mean, the only way Na is not going to get out of there is if it's being held captive by chlorine. I mean, so. Okay. So what about next? Who does silver want to replace? Who does silver want to replace?
Silver wants to replace SN.
Sn. So can silver replace tin?
No.
Silver's down on the bottom.
Silver's here, tin's here. No. Yes, Mackenzie.
How do you know what aging would replace?
Like replaces like. Li is a metal. It'll become a positive. It wants to replace the positive in the reaction. Okay? Yes.
The one that wants to kick it out will take like the C out.
Oh.
Huh?
The one that wants to kick it out will take the one that's not being.
Yes. So who does Na want to kick out here? K. Can Na kick out K? No.
No, sirree.
And next, barium and calcium fluoride. Will this happen? Yes, it will happen. And we will end up with calcium by itself in the corner while barium and fluorine dance away.
So it doesn't matter what order you put them in.
It doesn't matter what order you put them in. No. Any questions on that? Hold on.
Am I doing this right? These are the balance.
It should be. Yeah. It's fine. Okay. Last one. What about here? Who wants to replace who? And number 6.
Zinc replaces hydrogen.
Number 6.
Chlorine replaces bromine.
Chlorine is a nonmetal, and it wants to replace bromine. Which is the nonmetal? Will this reaction occur? Yes. And we will get NaCl and Br2.
Interrupt, or please excuse this interruption. Our first wave of spring groups. We want to wish everybody good luck. We've got kids all over the place. Skills USA. We've got kids in Corpus Christi with.
So, chlorine kicks out bromine, nonmetal kicks out nonmetal, negative kicks out negative, however you want to look at it. And we end up with that reaction and balance it. And then last one, look at number 8. Can platinum kick out? Who's it want to kick out? Na. Can that occur? No. No reaction. Are there any questions? That is your homework for tonight. Okay, that's fine.
No, I don't.